This is grade 5, module 5, lesson 2, and the objective in this module is to find the volume of a right rectangular prism by packing with cubic units and counting. So we're going to look at question number 1 from the homework, and it's letter A. It says, make the following boxes on centimeter grid paper. Cut and fold each to make 3 open boxes. Tape them so they hold their shape. How many cubes would fill each box? Explain how you found the number. All right, so once they make this on centimeter grid paper, it would fold up to be an open box, and that just means that there's no top, there's no lid on that. So this is just a rough drawing of what my box would look like if I put cubes in it and if I filled with the cubes. So what they're folding, they would have this side here, which is this side right here, and then this side along here is right here. Okay, and then this side and this side you can't see in the diagram, but they would be along here and here. So if I filled this box, you can clearly see that 4 cubes would fit in the box. So how many cubes would fill each box? The answer would be 4. Okay, and explain how you found the number. Well, I just drew a diagram here, and that's also acceptable from the students. As they go on with the homework, the students will start to realize that if I brought these sides out, that's really just adding another layer of cubes. So they're almost like building a tower. So that would be adding another layer. So now you would have 2 layers, and you can add another one for 3 layers. So if they have 2 of these sections on the side, like this one here and this one here, that would be the layers. And then the shaded part is on the bottom. That's where the cubes would go. Okay, so let's take a look at question number 2. And question number 2 reads, how many centimeter cubes would fit inside each box? Explain your answer using words and diagrams on the box. Okay, so we have number 2A, and so the number of cubes, let's take a look at that. The ones that I could see are right here. I have 1, 2, 3 here that I can see. This is the side of one here. That's 3, and then I see one that's right here. There's 4. Well, I know that there's 1 here that's hidden, 5, and then the one behind here, that's 6. So the number of cubes is 6. Another way a student can solve this is they could take a look at the number of cubes in the front here. And as you can see, there's 1, 2, 3, okay? So there's 3 cubes in the front. Well, they can also see how many rows of those cubes they have, and that's going to be right here on the side. So they have 1 row, and this is 2 rows. So I like to show the students that way, that they have actually 2 rows of 3 cubes. So like they can write that as their explanation as well. So let's do that. Now the students are very familiar with the rows. So there are 2 rows of 3 cubes. They could imagine it like this. So I have 3 cubes, and I have 2 rows, which brings an array, which they've learned in the past, and they've learned that this can be represented as 3 times 2, or 2 times 3. So there are 2 rows of 3 cubes. That actually could be a multiplication problem of 2 times 3 equals 6 to get an answer of 6 cubes.